Mic check. Good morning, or good day if you're watching the video later. I can see War Dog, so hello War Dog, I hope you're doing well today. And then everyone else who's out there, hope you're doing well. We don't have a super long meeting together today because the content is fairly minimal. Good morning, Justin. So we don't have a huge amount of content today, so you'll probably be relieved about that. I mean, I'll make sure that I don't speed through it, but our main job is to create a shell script, make the shell script executable, and execute the shell script. That's our main goal for the week. And then we'll have to introduce a couple of tools for doing shell scripting so that we can actually do something and watch it execute. So we're on shell scripts. We are in week 13, so we're on shell scripts. And the rest of the semester is just building on this. So we're just going to get a little bit fancier, add a new technique or two every week for the remainder of the semester, until hopefully you have the ability, usually if you're like me with the assistance of looking up some documentation, to actually craft a shell script. If you are a system administrator, then you probably already use shell scripts or are aware of people using them, but the shell scripts are a great way to capture sets of commands that you often find yourself repeating, and sometimes you're going to find yourself repeating a whole bunch of commands in sequence. And shell scripts are a great way to capture a sequence of commands and make them reusable so that you don't have to memorize them. You just put them in a file, and then you make the file executable, and then whenever you need that sequence of commands, you execute them. There's, of course, if you're a system administrator type, you can probably already imagine the many administrative tasks that you perform on a regular basis, and shell scripts are a great way to automate your administrative tasks. If you are a developer type like me, I use shell scripts for the same reason. I use them to set up projects in different programming languages. I use them to manage my compiling and my cleanup around projects. I use them to manage connecting to web servers when I upload files, a variety of things. So they're super useful. They do require a minimal amount of programming skill once we get there, which is why for most of you, you will have had at least an introductory programming class, which empowers you to take the greatest advantage of the scripting capabilities in Linux. Okay, so we're in week 13. I will remind you, and I know that it's challenging to do this when we're online, but I have a responsibility to try to create at least a couple of situations where you can interact more directly with each other. So we have another team project. It is exactly the same as the first one. So you won't have precisely the same team. The Canvas will have probably given you a slightly different mix of team members, I think. Anyway, you'll have a team, you'll get together, communicate with each other, pick a distribution, and then produce that same summary document that we did on the first team project. I'll talk about this next week, but I'm going to enhance this with a link to a anonymized example from the first project. So one team had a particularly good idea to show how everyone contributed within the document itself. So I'm going to anonymize that, take the names out, and add that as a link to Team Project 2. And I'll probably post an announcement when I do that. So next week I will talk about that. But please note that Team Project 2 is due, how many weeks is that? It's 3 weeks roughly from now. So we have classes normal next week. Butte College conducts classes during the week of Thanksgiving. So we'll be back here on Tuesday, and I will remind you again about Team Project 2. But the time to start communicating is now, I would recommend. Okay. So let's walk through what we will expect to encounter this week, week 13. So the goals, you'll notice, by the way, when you go to do the lab this week, there's only 10 questions. And what I've tried to do in the lab is create questions that are also sort of additional learning opportunities. And what I mean by that is when you're doing the questions, you should see, very often you'll see complete shell scripts or parts of shell scripts. So my hope is that when you're doing the lab, you'll actually take those ideas in the questions and try them. And then you'll know for certain that your answers are right. So I've tried to add additional learning opportunities and experimentation opportunities in the questions themselves. Okay, so what are we up to this week? Make sure that we walk away understanding what is a shell script and what do we use them for. How do you create one, which we're going to do together right now. And then specific techniques for shell scripts, which include creating variables and producing outputs. We're also going to do some inputs, although technically that's an official feature for next week's shell scripts. But I am going to do some inputs as well. And then how do you put notes or comments inside of a shell script? So not a whole lot of content, which hopefully gives you plenty of time to get the basics right and to make sure that you know how to create one and make it executable. So just one section of reading this week. The lab assignment only has 10 questions this week, so a little bit less than normal. You'll see me doing this for the remaining weeks. It's quite difficult to write what feel like questions with a purpose about shell scripting. So a lot of the questions are really asking you to create a shell script and execute it and see what it does. So there's fewer questions, but a little bit more of asking for your time to actually type out some shell scripts, make them executable, execute them. So you get a good feeling for that. So the prompt this week is adding, this is sort of to build up to some bonus content. So we've done window managers, or at least some of you probably have by now installed a window manager. So we're going to add a desktop environment to the mix. So the Piazza discussion is asking you to go out there and look at what desktop environments are available on Linux, and then vote on a desktop environment that we will install together. The difference between a window manager and a desktop environment. So a window manager is literally just the bare minimum of software to run an application in a window. Window managers do very little other than actually give you the ability to open an application in a window. A desktop environment is what you're used to if you've used a Mac or a Windows machine. Desktop environments come with a whole bunch of software, not just the ability to run things in Windows, but a whole bunch of software on top of that, screensavers, the ability to change the background image. They will come with sometimes games pre-installed. They'll come with configuration utilities pre-installed. So desktop environments is like the full-on graphical user interface with all of the pre-installed goodies that you're used to. So that'll be another thing that we'll install after you've voted on what you want to see me do a walkthrough on. And then the last bonus content toward the end of the semester will be to ask you what kind of service would you like me to install, like a web server or a secure shell server or something along those lines. So this is part 2, the desktop environment discussion of the bonus content stuff. And the last is the reminder, so lab as usual, discussion as usual, and then Team Project 2, which has the exact same parameters as Team Project 1, is out there and it's coming up sooner than later. So I highly recommend that you start communicating because you have Thanksgiving and a lot of people are going to go quiet for a few days over Thanksgiving. So you might want to communicate about that. Okay, so now let's go do shell script stuff. You can see what I'm seeing. Okay, so one thing to note here, that I'm already logged in. Anything that you can do on the command line, you can do in a shell script. So on the command line, you can create variables. I can say, I can make a variable. I often make my variables all uppercase letters. That follows the pattern that Bash uses. So it's easy for me to remember when I'm looking at a script that the things in all capital letters are my variables. So I can say that the weather is, I don't know what it's like for you guys today, but here it's sunny. So that's a variable. All that means is that I have this thing, this label weather, inside of my shell right now that has the value sunny stored in it. And I can use echo statements with the $ on the variable to print out on the screen the value. So the $ is the value of the weather variable, which is sunny. You can overwrite these things. The quotes are important here. If you don't put the quotes, you'll get an error, I think. You should. Anyway, so I can change the value of my weather variable, and then when I print it out again, I get the new value. So that's creating a variable on the command line and printing the value of a variable on the command line. And one thing to remember is literally anything you can do on the command line, you can do in a shell script. So every command that we've run the entire semester, you can actually run that command from inside of a shell script. And I might put a couple of examples just for fun about that. Okay, so don't forget that. The whole idea of a shell script is to take commands that you might otherwise type and execute on the command line and gather them up into a file so that you can now use the file to automate the execution of those commands, which is quite nice. So now let's make a shell script. I might have a folder for this. Yeah, week 14. Wait, we're week 13. Okay, I've already got a, let me remove that backup file. Oh, I have an alias for remove. That's fine. That's fine. It's just going to pester me about that. Okay, so let's make a shell script. So we're going to create a file. Let me make sure I don't overwrite something. Okay, so I'm going to make a file. I'm going to call it hello.sh. The .sh part is totally optional. Some people will put .bash there, but the extension part of a shell script, you don't even need one, is totally optional in Linux. Whether or not it will be executable is a matter of if its permissions say executable and that there are things inside of it that can be executed. So you can make them a .txt file if you wanted. You could say .script if you wanted. I tend to just say .sh, which is pretty common in the Linux world. So that's my preferred extension, .sh, for my shell scripts. All that does is tell me when I do a listing that that thing with .sh on it is probably a shell script. Okay, so we're going to just do what we just did on the command line. One thing to note here, by the way, notice how I don't have any spaces. Don't put spaces around that equals. That actually matters. So whether no space before the equals sign goes in, and then I'll say sunny and warm. You can put whatever you have, warm. And then the same echo statement. I'm going to space it out. Hopefully you can read that a little bit better. So echo, the weather today is, so you can actually mix just sort of your own text with variables. And the shell knows the difference because if you need the value of a variable, you put a $ in front of it. If you don't put the $ in front of weather here, it's just going to say weather in all capital letters. So there's a shell script. It's simply a sequence of creating a variable and then using an echo statement to print out the value of that variable. That's all it is. If you want to, by the way, you can execute the date command, which will cause the output of the date command to execute, followed by your printout, your echo statement. So you can put any command that you would run on the command line, you can put inside of a shell script, and the shell will execute it. Okay, so I'm going to write and then quit. I'm going to write it first and then I'll quit it. So I just want you to see on the screen that that is my file, hello.sh. Has 3 commands in it. One of the commands is really just passive. It just creates a variable and stores some information in it. Then my script says execute the date command, and then my script has an echo statement which prints out the weather today is, and then because the $ is here, it'll go grab the value of weather and say sunny is warm. In fact, I think I would like it to have a period there because I think that would look nice. It's also nice, by the way, that the VI editor already knows how to make the colors show me what's going on, so we call this syntax highlighting. You probably know that. Okay, so let's write and quit. I'm going to do a listing. I just want to show you the listing. So I have 2 shell scripts that are part of the hands-on experiments for this week. You'll see them if you look at the hands-on experiments page. They're green, and what that tells me is that those have been made to be executable. So one thing to note is that Linux systems will not allow you to make things executable. By default, you have to purposely manually make them executable. So the reason why hello.sh is not green is because it is not presently executable, which means that the shell will not execute the commands that are inside of it. I'm going to do a long listing just to show you what the permissions are. So notice that the ribbit shell script and the start shell script, this is the user read, write, and execute. So the user has execute permission on these other shell scripts, which is what I tend to do when I'm making a shell script for myself, is simply make it executable for myself. So if we want the commands in here to be executed by the shell, we have to make the script itself executable. So we're going to use change mode for that. I'm going to add for user execute. That's all I need to do on that new script. And then I'll pause there for a second just to make sure you have a chance to get it. But the commands inside of your shell script are meaningless unless the shell script itself has been set to be executable, and you have to do that manually with change mode. So change mode, user add execute hello.sh. If I do a long listing now, it's green because it is seen to be executable, and then notice that the executable bit for user is executable. Okay, I'm going to do something slightly wrong just to call your attention to it. If you try to do hello.sh and you want the shell to execute it, you're going to see command not found, and this is kind of review. But if you just slap a command on the command line like I did, the only way the shell is going to find that command is if your present working directory happens to be on your path, big P path. So because I just slapped hello.sh on the command line and I get a command not found, that tells me that the directory I'm in is not on my big P path. That's fine. I want to point that out. It won't just execute by typing out the file name, because if you just type out something like a command, or that's meant to be a command, the shell has to be able to find it on your big path to execute it. So this is where we need to use relative path. So we need to tell the shell, in this folder, execute this file, so that the shell doesn't have to look through my big path settings. I'm just telling it specifically this thing in this folder, and now it will execute it. So there's the output of the date command, and there's the output of my echo command. So because hello.sh, because this folder is not on my big P path, I can't just type hello.sh. I have to provide, in this case, I provided a relative path to it. Otherwise, the shell has doesn't know where to look, including the present working directory. All right, so that's important. Okay, so we made a file. I used the .sh extension on my systems as a signal to myself that that is probably a shell script. We made it executable, and then we used a relative path to execute it, and it executed all of the commands inside. So obviously it did the variable because the date is there. There's the date command, and there's my echo command. Okay, so that's step one. So now we know how to create the script, which is just shell commands, make it executable, and use a relative path to cause it to execute. So let's go improve upon our script a little bit. Okay, so I'm going to add a new line at the top. By the way, in VI, the way I did that, so I put my cursor on the first line, and then while I'm in command mode, escape, while I'm in command mode, I do a capital O, which opens the line above. So that opened a new line, and it put me into insert mode, so now I can start typing. So we're going to improve upon this shell script. Okay. Sorry, I got distracted for a second. Okay, so we're going to improve upon this shell script. This step is going to be a little bit harder to understand, but very often at the top of shell scripts, you're going to see what's called the shebang. So that's the hash symbol followed by an exclamation point, but if you Google it, you'll see that a lot of people call this the shebang. And the purpose of the shebang is to guarantee that the commands in this file are executed by a specific shell or interpreter. So we are writing commands that we intend to be executed inside of bash. So with our shebang, we're going to put, we may have to edit this when I look it up, but what we're doing here is all we're saying is the commands that follow this shebang line, I want them to be executed by bash. I want them to be interpreted by bash. On a system with a lot of users, you may have people running different shells like the corn shell or the Z shell or the C shell. There's lots of shells. Fish I like. So the point of this shebang is no matter what shell someone's executing it in, the shell commands themselves are going to be interpreted by bash. That's important because the scripting rules may be different from one shell to another. So I've written this script to follow bash's scripting rules, and the shebang line guarantees that these commands are going to be interpreted by bash. So that's what the shebang is for. You can see that in the notes on the right. I put the word shebang. That's what that means. So all these commands, I intend for them to be interpreted by the bash shell. One thing we need to do is make sure that this is, in fact, the location of the bash shell on this system. So I'm going to hit escape, and without exiting VI, I'm going to go colon bang. If you look down here at the bottom, colon bang, I'm going to type which bash, and so I just wanted to see very quickly where bash is in my system. It's actually in user bin bash, so I need to fix my shebang line. But you can actually execute shell commands inside of VI, and occasionally that's a convenience. So colon bang, and then the command I wanted to execute was which bash, and the output of that was user bin bash, so I need to update my shebang line. So I'm going to press enter like it's telling me. Bash on my system is actually in this location, user bin bash, which is why I went through those steps. So all I did was use the which, W-H-I-C-H command. I just did it from inside of VI. But if in doubt, just write and quit your shell script, do a which bash on the command line, and then come back knowing what it is, right? So this just says, on this system, when these commands are executed, I want bash to be the one to execute them. That way, since I'm writing shell scripts using the bash syntax, this is all guaranteed to work. Even if I were to switch the shell that I'm actually running as a user, my script would still work as desired. Okay, so that's the shebang line. Let's add some other stuff just for fun. So the weather today is, of course, that's just made up. We can do additional variables though. What do I want? I don't know. Let's do I want that? Well, I'll just make up. I'll do something off the assignment. So I'm adding more variables just to show you can do that. But I also wanted to show you that you can echo more than one variable on a line if you want to. So this morning I didn't actually, but so I had a drink and food. Just to show you that you can actually put as many variables on a line as you want to. So you can, this is kind of the Mad Libs thing, if you've heard of that. Sort of fill in the blanks with words. And I'm going to just preview for you. Just show you a little bit of interactive stuff. So you can actually make a script so that it asks the person running it questions, and then you can read in their answers. So you can actually make a shell variable by reading someone's keyboard input. So what this read does is it causes the shell script to sit there and wait until your user types something, and then captures what they type in a variable, and then you can echo that out. I'll put a colon in there, and then so this is a preview, but you can actually in a shell script capture keyboard input, so you can ask your user questions and then read in their answers, and then use those answers to print out new stuff. So I did a lot. I'm going to pause on that for a sec. Actually, I'm going to go down a line just to get the cursor off there. So that if you're working along with me, you can capture that. Okay, hopefully that's all right. So I'm going to write and quit, and I'm going to re-execute it. Remember, you have to use the, it's executable, so that's all good. If you edit an executable file, it doesn't change its permission, so it's still executable, but it's not, this directory is not on my path, so I have to give it, in this case, I can give it a relative or an absolute path, but a relative is path. Present working directory, file name hello.sh is faster. So there's the date command, there's my first echo, there's my second, coffee and donuts, there's the question, and then now it's waiting, so that read command is sitting there waiting for me to type a word. I don't have a word. Basketball. I don't know. I just want to show you. So when I press enter, the read command is going to capture what I typed in that word variable, and then the next output is going to print out that the value of that word variable. So the word of the day is basketball. So you can make interactive scripts, which can be super handy for a script that you don't use every day. So sometimes you forget the information that it might need, like which user do you want to look at the login files for, or that kind of thing. It allows you to sort of change the behavior of the script by typing in the information that's needed right then. Okay, so I'm going to go back in to my script and just show you a couple of other things. So you may have noticed for this output command, what is the word of the day? You may notice that the cursor dropped to the next line down. So there's two ways to make the cursor not drop to the next line down. Let me get into insert mode. Insert, there we go. So one way to have the cursor not drop down is to put -n. And what -n does, it says print out the string, but no line break, no new line. So without a line break, meaning it's going to print that stuff out and then put the cursor at the end of that line. So we'll just say notice I'm putting an extra space here. And the reason I'm doing that is because when this prints, it's going to print, because of that -n, it's going to print all that, and then the cursor is going to sit here just past one space, but remaining on the same line. And then I'll read a month. So you'll see what this, when we run it, you'll see the difference here. There's a way to make lines 17 and 18 to combine that all up into just one single line, which is to use the read command with a prompt option. So you can say read with a prompt. So instead of separating out the question from the reading in the variable, you can actually, the prompt or the question, you can include the prompt on the same line as the reading the variable. So line 20 has the same effect as lines 17 and 18. It just does it all combined in one place. So you can read, you can echo your question, or you can read with a prompt and include the question in the read string. So 17 and 18 ask for the month in 2 lines. 20 asks for and gets the day in 1. I'm going to put a blank line in. So to get a blank line, just echo nothing. Before I echo, so your birthday is month, day. It's kind of meaningless, but I wanted to show you, if you echo with the -n, it will not put a new line at the end, so no new line. If you read with a -p, that allows you to incorporate the prompt into the reading command, so you get both at once. That's all those mean. Okay, I'm doing pretty good on time. Hopefully these pauses are usable. I'm quite pleased, by the way, with the way VI does syntax highlighting, which is VI highlights things with different colors to show you kind of what's different and what things mean. So that's very, very useful, that everything that's blue should be the value of a variable. Everything that's, not all things, but the variables by themselves are in turquoise, kind of, or whatever you call that color. Anyway, you see. Okay, let's run this script and see if it does all the stuff. So remember, this is really just a series of questions where the user is typing in an answer. So lines 13 and 14 asks a question and then reads in the answer on the next line down. Hold on, let me do a block. Line 17 and 18 ask a question, and then the answer happens on the same line as the question. And I'll show you this when I run it. And then line 20 on the same line as the question, but you sort of gather up the question and the variable and reading all in one place. So line 20 is by far the most efficient way to do this stuff. So I'm going to write and quit, and then echo the thing. All right, so here's the first question, and notice that the cursor's on the next line down. So I echoed, what is the word of the day? I'll say sneakers. Okay, so notice the second question, the cursor and my answer are going to be on the same line, and that's because that one was echoed with -n, which means don't line break, print it, and then put the cursor at the end of the line. So that has a different look to it. One, I type my answer on the next line down. The second one, I type my answer on the same line as the question, which I happen to like that look. And then the third one, notice, that one's the read-p. So it reads, the read-p prints the prompt, and then on the same, on the same line, you type your answer. So I happen to like the type your answer on the same line look. That's just a personal preference. But you also have the option of type your answer the next line below the question if that's your preference. There's the blank line in there, by the way. That was the echo nothing. And then here's my final echo, which is the month and the date that were the answers given to the questions. Okay, so if you know what Mad Libs are, it's like super easy to do Mad Libs this way. All right, one more scripting example, and then we'll talk about the last thing, which is putting scripts on your path, or the way I do it. So I'm going to do one more. So I just want to show you that you can actually write scripts where you can have people, I don't recommend this, but I'm going to do an echo -n. So I'm going to echo this question, put an extra space in because I think that looks nice. No new line, so the answer is going to go on that line. And then I'm going to do a read -s. So the -s means read silently, and you'll see what that means in just a second. So read silently, secret. Now it's a bad idea to write shell scripts that have people typing in passwords, but it's a thing that you in theory can do. But what you do basically is you introduce into the shell environment a password. Okay, but I want to show you what the -s does. Let's put an extra blank line up here. just so the birthday output and the secret word question come on with a space between them. Okay, so going to read in secret. So one thing I would just want to point out to you is reading silently, and you'll see what that means in just a second. The information is still in there, so let's just try this -S one. It's going to make us do all these other things. Oh, we've got to do comments, but let's do read silently and then a couple more things. Okay, so I'm going to write and quit this. So that last section, I'm going to print out a blank line just to make it easier to find this stuff on the screen. Echo without a new line character, the question, what is the secret word? I put a space down here because I like the way that looks on the screen. Then we're going to read -S, which is a silent read for a variable called secret, and then we're going to print out the secret. Okay, word of the day. Why I fixed the spelling, I don't know. Okay, so I haven't typed anything yet. But this is the echo -N for what is the secret word, followed by a space. And because there was a -N, the cursor is going to be sitting there. Now watch what happens when I type with the -S option. So the -S means read silently, and that means that as they're typing, the characters they type don't appear on the screen in front of them. So when I press enter, what I typed is going to appear on the screen, but the -S means that while they're typing it, it doesn't actually show anything on the screen, which is a way, I guess, to hide some information. So there's the secret is apples. By the way, on the same line. So I need to put a blank line in there. So I typed apples on that -S. So that's kind of cool that you can do that. Although be careful of things like that where you're asking people for, if you're a system administrator, I'd shy away from asking them for important information like that. You just never know. Okay, so before I print the secret, I'm going to put another blank line in there. So that was all that -S stuff. Okay, so one more thing in the script, and then we will put this script in a folder on our path so you can see how that works. So I'm going to go to the very top. I'm actually going to start at the line below the shebang. So you can put comments just like you can in any other programming language. You can put comments in a shell script, and the way you do that is with the hash symbol. So when the shell sees a hash and a space, as long as it's not a shebang, but if the shell sees a hash, then what you're telling the shell is all this stuff is not commands, this is just a note to myself. So I'll put a little note to myself. So this is a comment. Comments start with hashes. So I'm just putting a note here about when I created the script. And a note about what it is that it does. So those are comments. You can see how they're highlighted. There is a question about that. So the way you make a comment in the shell script is with the hash symbol or the pound sign. That's distinct from the shebang, which is special. It's just the pound sign by itself. You can add comments at the end of lines. I don't tend to do that very much, but from the point where the shell sees that hash symbol, from there to for the rest of that line, it's just going to ignore it and assume it's just meant to be a comment. So that's how you put comments in the shell script, and that's very useful for noting who wrote it, what it was meant to do, if there's any bugs in it, that kind of stuff. So those are comments in the shell script. Oh, I just hit all the honey was pooled at the bottom of my cup, and I just hit all the honey, so... okay, so you're going to see some things very, very similar to this in the hands-on experiments. Two very similar scripts that show you a whole bunch of different things. I think there's even a goodie there about seeing if they typed in the secret correctly. Okay, so before I close this script, just one thing to note. When you're doing hands-on experiments, if you do use my hands-on experiments, in many cases, the spacing matters. So for here on line 12 as an example, the spaces around this equal sign matter. So a good rule of thumb is if I don't put spaces, then you probably shouldn't. Or if you do, just expect that possibly it will break. So be careful about the spacing of things, because that usually matters. Okay, so that's our shell scripting walkthrough. So now let's talk about this thing, big P path. So let's say that I think my hello shell script is a super great shell script, and I just want it to be available to me whenever I want, and I don't want to have to find the path to it, and I don't want to have to do relative or absolute path. I just want it to be on my big P path, so I can type hello.sh and it will just execute. So that's the last two things in my notes here. One idea for doing that. So one idea for doing that, I'm going to note where I left that from, is to go to your home. I hope I don't have one already, do I? I don't. So I'm going to do this just to be on the safe side. But anyway, you can make yourself a scripts directory. I would probably put it off of my home. So you can make a scripts directory, step one. And then move the script that you want to be like you're always available to you script. So move, mine is in my week 13 folder. So I used a relative path from my home into my week 13 folder and then grabbed my hello.sh. So I'm going to actually move that into my scripts folder in my home. So if I go look in scripts, I'll show you that that's where I'm at. I'm in home user scripts. If I go look in there, there's the script. Okay, so that's step two. Make yourself a scripts directory off your home. Move your script to your scripts directory. And then the last step is to add scripts to your path. So the way we're going to do that is by editing bash rc. Let me fix that. So we're going to add this scripts folder to our path, and that way everything that's in our script folder becomes just a command that we can type on the command line. So I'm going to edit my bash rc. I don't think I need this echo statement anymore, so I'm actually going to use this shell scripting commenting to disable it. And then I'm going to do, let's make sure we echo. Okay, so what we want to do is add that scripts folder to our big P path. And the way you do this the way I'm going to do it is I'm going to overwrite path. I'm going to start by using what my current path is, so don't lose your current path is what this means. So take my current path, keep it, and then add on to that scripts folder. So now the new value for my big P path will be what it already was with the addition, that's what the colon is for, with the addition of my scripts folder. By doing that, all of the executable scripts in my scripts folder become just commands. I don't have to offer absolute or relative path to them. I can just type them as commands. So I'm going to overwrite path with what the current value of the path is, so I don't lose what it currently is. I still want all that stuff. And then append to that the scripts folder that I made. And now all of those scripts inside of that folder become commands on my path. Alright, so I'm going to just point out to you, if I echo path now, there's my current value. And notice scripts isn't on here. And the reason why scripts is not on here is because that change to my bash RC has not been processed by the shell. So there's two ways to get the changes to process. One is to log out and to log back in. Maybe I should have put it in... oh, that's fine. So you could log out and log back in, but what we're going to do is we're just going to source it. So we did this maybe last week or the week before. If you make a change to a dot file, you don't have to log out. You can source it, which is a way to force the shell to reread its contents. And then if I echo path, notice that my scripts is now on there, which means now I can run that script without the relative or absolute path on it, because now it's just considered another command on my path. So that's kind of cool. So it's a little bit of bonus, but if you get a really cool shell script and you want it to be sort of constantly available as if it were just another command, you can put it somewhere and put that somewhere on your big P path. This is what we did on those last steps. Let me save this file. And I'm dawdling a little bit just to make sure that if any questions come through, I get them. Okay, so that's my whole show. Hopefully that's useful. If it's interesting, that's even better, but hopefully it's useful to you. I find this part of the work quite fun. It is a very empowering feeling to know that I can automate tasks like this, and I can create myself simple little programs in the form of shell scripts that assist me in whatever work it is that I'm doing. Super useful for system administrators, but like I said, I also use it as a developer pretty often, actually. And I'll show you more examples of that as we go, the kinds of things I use them for. Okay, anyway, that's the basics. That's what I have for today. I ended up using most of the hour. So thank you for sitting here with me. If you're here later, thank you for watching later. Hope you have a great week. Hope you have a great day. And I will see you on Tuesday next week. It is Thanksgiving week, but Butte College still runs classes, so I will be here on the normal routine on Tuesday morning next week. So I'll see you then. Thanks, Justin. Take care.